today we'll be looking at the reactions of amines, okay? The reactions they undergo quite a lot of reactions, but we'll just look at a few reactions with respect to the exams. Okay, the first one I'll talk about is reaction of ammonia, 1 degree amine and 2 degree amine with acid chlorides and anhydrides. With acid chlorides and anhydrides, okay? So now, when we say reaction of ammonia, 1 degree and 2 degree amines with this, it means that tertiary amine might not undergo this reaction, okay? It means that tertiary amines might not undergo this reaction. So look at the reaction on the board. Remember that what you are seeing here, RC double bond OZ, this Z can be chlorine. If it's chlorine, it's acid chloride. If it is this value, it is acid anhydride. For example, what I mean is that if I replace this Z with Cl, what I will have here is reaction of acid chloride with what? Ammonia. So you understand. And this reaction, these amines, two molecules of these amines are reacting with this what? Acid chlorides. So what I mean is this. Look at the first one. The first one is simply showing the reaction of an acid something. It can be chloride, it can be acid anhydride. If Z is chlorine, it's acid chloride. If Z is this, it is acid anhydride. So if you react this with this, you have this. The end point of this reaction is that what is produced is called an amide. This reaction leads to the production of an amide. Okay? So if you are reacting ammonia with it, it will produce a primary amide. If you are reacting a 1 degree or a primary amine with acid chloride or acid anhydride, you get a secondary amide. Secondary amide. Then when you react an acid chloride or acid anhydride with a secondary amine, you get a tertiary amide. So now let's do a simple example. Let's use an example, a real example of what we are doing, okay? Let's picture any acid chloride. Let's use this acid chloride, CH3COCl. Let's use that example. Let's say we are reacting this with ammonia, NH3, okay? In this reaction, remember, I told you that what is reacting is 2 molecules of this guy, 2 moles of this guy. So in this reaction, what happens is that there is a nucleophilic substitution reaction taking place here, or nucleophilic addition reaction here. So in this reaction, the ammonia, NH2, will replace this chlorine. So I'll have CH3CONH2. Remember that I took out only NH2 from here. This is NH3, this is NH3. So if you take out 1 hydrogen from here, you have NH2 left, right? And this NH2 is what you are seeing here. So this extra hydrogen that is here will join this guy to give us NH4 plus the Cl. So ammonium chloride will come out here. Take note. Take note. So at the end of this reaction, when ethanoyl chloride reacts with 2 moles of ammonia, you have ethanamide and ammonium chloride. Let's do another example. Ethanoyl chloride. Let's say we have CH3COCl plus, let's react it with what? A primary amine. A primary amine. Let's use methyl amine as a case study. In this reaction, remember that 2 moles of this guy is reacting. So in this reaction, if this reacts with this, the hydrogen from this ethylamine, one of the hydrogens is going to eliminate. So that, remember, I told you have CH3NH2. You also have CH3NH2. So one of these will react with this. They will exchange, chlorine will leave. Then CH3NH, 1 hydrogen will leave here. And then the rest will replace this. I will have CH3CONHCH3. Now, 1 hydrogen will leave here and then combine with this chlorine and this guy to give us plus CH3NH3Cl. you have this. So that is the product of the reaction. So at the end of this reaction, you notice that this first one gave us a primary amide. This second one gave us a secondary amide. Let's do one more example using a secondary amide. So for example, let's say we have CH3 COCl plus 2 moles of CH3 NHCH3 of this guy now. So if you are reacting it with this guy, what are you going to have? The same thing will happen, okay? This hydrogen, one of it is going to leave, so this will join with this guy. So I'm going to have CH3 CO, and this N now has 2 methyl. So I can open bracket here. I can write N open bracket CH3 close. I'll put 2 inside here, plus the remaining thing here CH3 NH2. I can put this in bracket, then I'll put Cl. So this is the product of the reaction. So this might not make sense, but take time and watch the video, you understand what I'm saying, okay? Now, if I'm to use an acid anhydride for this reaction, if I'm to use this for the reaction, it's still the same thing, okay? So, but we're not going to use that so I will not confuse you anymore. So this is a reaction of ammonia, 1 degree amine and 2 degree amine to produce primary amide, secondary amide, and tertiary amide. So this one gave us a tertiary amide, right? Why this one gave us a secondary amide, right? Secondary amide. Then this one gave us a primary amide. So the 3 reactions I've done here produce a 1 degree amide for this. This one produce a 2 degree amide, while this produce a 3 degree amide. So take note of these reactions, okay? The next reaction we'll talk about is Hoffman elimination. Now, for Hoffman elimination, we are eliminating the amine functional group. We are eliminating ammonia from the amine, okay, to get an alkane. The end product of this elimination is to produce an alkane. So the reagent we use for this reaction is methyl iodide, silver oxide, and then you apply heat. So in this reaction, we'll have, let's say we have this amine. So this reaction is a beta elimination, okay? So you remember that if you have this amine somewhere here, let's say this is an amine, for example, okay? Hydrogen, this is an amine. Now, the carbon that is connected to the nitrogen directly, the beta, this is the alpha carbon, this is the beta carbon, okay? This is an alpha carbon, this is the beta carbon. So the elimination is an alpha beta elimination, sort of elimination of these 2 molecules from here. So this elimination can be carried out using methyl iodide in excess, okay? In excess, this should be in excess, sort of, right? Then you, in the presence of silver oxide, then you apply heat, okay? So in this reaction, it will lead to the elimination of these 2 molecules here, okay? So when this eliminates, you now have carbon, double bond, carbon. Remember, you still have something attached to this place, okay? So plus the byproduct. The byproducts will include water plus butyl amine, sort of. This is CH3, a tertiary amine, plus silver iodide. So all these are byproducts. They are not really important. They are called byproducts. So the main product of this Hoffman elimination is an alkane. Okay, is an alkane. For example, let's do one single elimination reaction now. Let's say we have CH3, CH2, let's use propylamine. Then we have CH2, NH2. Okay, and let's carry out this Hoffman elimination using all these reagents here: CH3I, silver oxide, then heat. Okay, in this reaction, we are going to eliminate this amine here and eliminate 1 hydrogen from here. Just the same way we did for dehydration of alcohols, that's the same thing you're going to do here. So when you remove this amine and remove one hydrogen from here, you have CH3, CH double bond, CH2, right? Then plus your byproducts. Your byproducts includes water plus your N methyl ethylamine, something like this. No, this should be N, not this, should be like this. So N CH3 close 3, then plus AgI. So the product of this reaction is called propane. This is the product of this reaction. So when you undergo Hofmann elimination of propylamine, this is propylamine, of propylamine, you will get propane. That is the end product of this Hofmann elimination. So the next reaction we'll look at is reaction of amines with nitrous acids. Okay, this reaction for primary amines will react with nitrous acid to form an alkyl diazonium salt. Okay, it will form an alkyl diazonium salt, while aromatic amines will react with this nitrous acid to form an aryl, AROYL, an aryl diazonium salt. Now this diazonium salt is important because we use this diazonium salt to synthesize a lot of compounds using the Sand-Meyer's reaction. Okay, I don't know if you've heard about Sand-Meyer's reaction, but if you're not heard about it, don't worry. I don't think we have to talk much about it. The Sand-Meyer's reaction. Okay, so these diazonium salts are very important. They are very important intermediate. Okay, so we use them to synthesize as multiple or complex aromatic compounds or aliphatic compounds, depending on the particular one you are using, whether the aryl diazonium salt or the alkyl diazonium salt. So for this reaction, if the amine is a primary amine, this is a 1 degree amine. Okay, 1 degree amine will react with this nitrous acid. Nitrous acid is HNO2. In the presence of HCl, this will give us R, N triple bond N with chlorine. Okay, so this is the positive charge, negative side. So this is what we call, this is the alkyl diazonium salt. Okay, the alkyl diazonium salt. Okay, so if say a primary or an aromatic amine, for example, let's say we have benzene now as a case study. Okay, this is NH2. So if we react this with also HNO2, HCl, we will have the same thing, but this time around, this one will be an aryl diazonium salt. Okay, so take note. So this one you are seeing here is called an aryl diazonium salt. Okay, the process for this reaction, this reaction of amine with nitrous acid, we can also use, in case you don't want to use this one, you can also use sodium nitrous, or like this. Okay, you can also use this one. So the process of, or the reaction, this reaction is called diazotization. Okay, so this reaction can also be called diazotization. But remember that if this is primary amine and aromatic amine, you get this. But if it is a secondary amine, for example, let's say we have this R, N, and we have another R here, and we have a, this is a secondary amine. For secondary amine undergoing this same reaction, let's use this as a case study. Let's use an HCl. For this reaction, what it will form is not going to be this thing. It will form what we call an N-nitrous amine. Okay, so what's an N-nitrous amine? You're going to remove this H and replace with what? A nitrous group. So we have R, N connected to N double bond O, then have this R. So this thing you're seeing here, we call it the N-nitrous amine. So N-nitrous amine, why is it N-nitrous? Because at the N nitrogen here, we have a nitrous group here, so it's called N-nitrous amine. So for secondary amine will form an N-nitrous amine. But for primary amine and aromatic amines, they will form diazonium salt, okay? And the process is called diazotization. These salts you are seeing here can further react to produce more important products in organic chemistry.